Okay, welcome to the business analysis and system design module. And last time we started looking at object modeling part. So I'm going to continue where we have stopped. We discussed up to use case diagrams. Today we are going to look at sequence diagrams, more on uh, implementation details on how we can use object-oriented modeling techniques. And remember, this is a very important part, especially if you're on to designing a software, especially if you are focusing on object-oriented, modeling, right? So let's first review what we have done last time. Now, remember this object-oriented analysis is very important if you are going to model a problem in object-oriented way, which is very common nowadays, and some of the problems inherently you can actually make more object-oriented way. So remember that it's very important that you learn the basics, right? And then this is a very popular choice when it comes to software development. So you should also know the keywords, and also you should know the steps of object-oriented analysis and design, right? The first task that we have discussed is what we mean by objects. So anything that we can actually represent in day-to-day lives, we can make it object. It could be a person, place, event, or even a transactions, which is very significant to our information system. So we have to keep, use idea of objects. And then we discuss how object look like. Usually when you talk about the objects, we have to talk about set of attributes as well as set of method which describes the object. So in representation, usually we can see three parts, parent, and then the set of attributes and set of methods. So this is usually we can talk about at the class, which is the main one. And then when you have specific values, we can talk about it as a instances of, a parent object, right? And then we discuss a couple of other objects as well. And attributes, which basically describe the characteristics you can inherit, you can acquire, or attributes from other objects, which we have discussed also, right? Now, when we have, two objects here, we have a student and instructor object. You can see we have different set of attributes. And then this is an event, or we can say it's a fitness class schedule. You can have a set of attributes, right? Now, when we have a methods, we talk about some specific task, and then depend on the method, there could be a set of steps that we have to follow within the method, which we describe, right? So here is another example for a method. And apart from attributes and the methods, the next thing that we should aware of messages between the objects. So especially when we have set of methods, now when to start the method actually based on the message passes. So these messages could initiate the a message passing among different objects, right? Okay, so you can see some messages as well, right? And then some of the ideas also we have discussed. So same message could mean different things for different objects. So in this example, we call polymorphism, which is the idea is the same thing. The message is good night, but for different object, it means different things, which is the idea of polymorphism. There could be many forms, in short, what it means. Then we will discuss about the classes. And then Classes, we can say it's kind of a template, which could, a class can have some common attributes and the methods. And then when we group objects, we can make the class. And then you can also have subclasses, which is more specific categories of the classes. Now, for example, here we see class vehicle, and the subclasses could be specific, cases like car, minivan, truck, and so on. Right. So here's another example. And then we can have some general relationships, like, for example, when we have a class, more generalized version of this is called superclass. More specialized version of this is called subclass. So if you take an employee in an organization, you can actually generalize to say a person, more generalized. But the same thing, if you have more specialized, like instructor, right, it is a subclass. So usually when we interact with the object orientation, we can always talk about the superclasses and subclasses. So when you have a class, usually you inherit from your superclass. That means all the attributes available in person is available for employees. We normally call inherits all the attributes from the superclass. And same goes here with. But subclasses, for example, apart from all the attributes you get from the superclass, there could be very specific set of attributes as well as some methods. Now, when you talk about relationships, it's very important that you need to, talk about the object relationships. So relationship, you can say in a way that what you should know about each other, how, objects should, respond to changes, how, when you talk about the membership of the classes and so on, right? So when you talk about the inheritance, which we have when you have an object which we call the child, you can derive from its attribute from another object, in this particular case, a parent object. Right, Ishan Rijal asked something about, so when you take parent and child relationship, we can normally say that child can inherit all the attributes and the method from the parent. And then child can also have very specific set of attributes and as well as method in child. Right, now, when it comes to object-oriented modeling, we talk about set of diagrams. And the very first one, we started by looking at what we call the object relationship diagram. Now, this shows you a set of objects and their relationships, right? So this will gives you the big picture, we can say overview of the system. Right, now here is an example. So we have employee, we have manager, office staff, instructor, fitness class schedule, registration record, fitness class, and the students. And the arrows shows you some relationships, right? And for example, the first relationship we see, it's actually membership, which we call managers as employee, and office staff is also employee, and instructor is also an employee. And then you can see the manager object, which determines the fitness class schedule. And then fitness class schedule will open up the fitness class, and office staff administrators and instructor will indicate the availability, which indicates leads to generate the roster as well as the adding a student. And then a student will take the fitness class and instructor will teach us the fitness class. So all these arrows, when you create these, indicates the relationships. So that's the first one. Usually, to represent the information system, commonly used language is called Unified Modeling Language, or in short, we call UML. So these can use to represent what we call use cases, use case diagram, class diagram, sequence diagram, state transition diagram, and activity diagram, and which is what we are going to discuss in the remaining sessions, right? And what we did at the end last time, we talk about what we call user case modeling. And user case modeling usually we use to identify the behavioral diagram or dynamic diagram, and we can represent some business situation. And usually you will have an actor and a use case. So in this example, you can see actor is the patient and use case is the make appointment, right? And then the arrow indicates the relation, right? So the patient is the one who actually, interact with the use case, right? So in this particular case, patient is actually requested to make the appointment. So here are like a couple of use cases. We have passenger request for make airline reservation, customer is requesting a place order, a bus dispatcher is requesting to change pickup address. Right now, the relationships, now these are like called general relationship, and there could be some very specific ones. Or for example, we can have users or include or extends. Now, when you say users, indicate user case is needed, right? So you need it to perform particular task, right? So when you say include or users, we need that relationship, right, to perform particular task. But when you say extends, right, so alternative options, right? So for certain user cases, there could be some alternative options. And then the arrow will indicate that what use case is actually being used. Now, according to this one, you can see now two cases. We have add fitness class. So in this particular case, actually uses the produce fitness class roster. So it uses, so you can say users indicate relationship indicating a use case is needed by another in order to perform the task. So to add class fitness class, right? So you need to produce fitness class roster. And then when we have instructor change availability, we have update instructor information. So we can say student is adds a fitness class and produce fitness class roster uses the results of this add fitness class to generate new fitness class roster. So once you have that, so this will be used, this add fitness class by the produce fitness class roster. Now, similarly, when we have an instructor, when we changes his availability, then we have to use the update instructor information. We have to change the availability to update the instructor's information. Now, when we have use case description, usually we will have all the possibilities. So it's a small description where we keep track of all the information. Usually we will use this for documentation. Now, for example, add new user use case, we can see we have the name for user case as add new student, and we will list all the actors are interacting. We have student and managers. Then description, that means description for this use case. If the use case is successful, then what will happen? If not, what will happen? Any preconditions, post conditions, and also you list any assumptions. So this will be a detailed description of the use case diagram, use cases. Now let's look at use case diagrams. It's we can say visually we represent the use cases within a system. So when you talk about the system, usually we have to identify the system boundary, and which we use a rectangle. And rectangle, we represent the system boundary. And then we can place the use cases. And usually we will have ovals we will use to represent them. And then we can add actors. Right. Now, we first identify the boundary, then we place the use case diagram, use cases, and then we add the actors, and then we show the relationships. So then we discuss couple of use case diagrams. We have, you can see here we have a rectangle box which indicates the system, or it could be even a subsystem. And then we can first we identify the boundary, and then we will put any use cases. So you can have, in this particular case, we have 3 use cases: create work order, update work schedule, and prepare invoice. And then you place any actors. Actors usually represent as stick figures, like these shapes we call stick figures. So in this particular case, we have 3 actors: customer and mechanic. And then from the system side, we have service writer. Right now, you can see. So both of these actually initiate, the create work order, which will eventually, work on other use cases. For example, once we have the create work order, it should update the update work schedule. At the same time, it should update the prepare invoice. So once you update it, that should notify the mechanic, and the mechanic has to perform the work so that you can prepare the invoice once the service right actually checks it, right? So that information is overall representation is given there. Similarly, another example, we have this one, we have create bus route. So we have 3 use cases here as well: create requirement forecast, prepare route plan, and develop staffing plan. And then we have 3 actors: student, driver, and dispatcher. And here are the arrows indicates the all the relationship among the use cases. Right. I have given some more examples. Now, for example, in this one, we have class registration. And remember that in this one, it's an iterative development. So you can see here, release 1 means initially we'll focus on several use cases. And then in the release 1, actually, we have 2 actors, right? And here is the relationships. Now then, in this next release, what happens, we have created another use case. And for that, we have another actor is involved in here, operator. And then the third release, you will have, another new use case. And then we have, actors. So this diagram actually indicates you like iterative development, especially in the beginning, you can focus on few use cases. And once you implement it, you can actually expand, right? So that is what we are going to, that is what it's actually representing in this diagram. Now, in this diagram, you can also see all the users and extents. Remember, I told you like some use cases, users. Now, for example, in this one, we have make new customer offer, which creating a new customer will actually uses this make a new customer offer. And then make customer offer, we have a very specific case where we update your customer information. So these are special representation. And here some like hierarchies as well. Now, for example, this indicates that, we have some hierarchy, right? So when you say make offer, you can have make new customer offer or make a customer offer. So, two possibilities. So likewise, stick figures also, you can see some relationship. Now, for example, customers, we can have, like superclass, subclass, we can have like two. For example, we can have new customers or we can have existing customers. So for a new customer, interact with this make new customer offer. And the existing customers, you already have some customer offer. That it indicates how, you can actually show model hierarchies. In this case, you can have user case hierarchies, some advanced, representation. And at your level, actually, I'm expecting you to learn at least up to this point. Although I have represented some more advanced examples, just to give you some idea like what these user case diagrams are capable of, right? Okay, now that we talk about the use case diagram, now what you do after that, you develop what we call class diagram. Now, class diagram, we can use to show or illustrate what we call the classes and then their relationships in a use case. So usually to create a class diagram, you get a use case and then you identify classes and then you can represent class diagram. Now, when you look at class diagrams, the representation, usually we use rectangle. And then in rectangle, in the top, we have the name. And then you list of attributes, and then you have set of methods. So that's how usually you represent a class. And then you can have lines for relationship. Now this is, you can similar to ER diagram, right? You can also, instead of entities, this time we have classes. And then instead of when we have relationships, we have just line which connecting these classes. So you can see here. So sales manager is one class, sales rep is another class, and we have managers relationships. So this can mean that, okay, sales manager manages 0 or more sales reps. So you can read it that manner. Right, now place labels identify action that relates to two classes. We can use different labels. So managers assigned to places includes, these are some of the labels. And then we can use to describe how instance of one class related to instance of another class by. specifying cardinality. You can talk about min max. So you have already learned this is even in ER diagrams. Slightly different notation here. For example, so this actually notation is actually sometimes we call min and max notation. Cardinality means when you take a one particular object, okay, and for a given relationship, how many objects actually relate with that relationship. Now, for example, if you take a one sales manager can manage 0 or more. 0 means the minimum number. That means there could be some managers without managing any of the sales representatives. Similarly, if you take sales representative, there will be only one manager manages him. So that's how we talk about the cardinalities. I'll come to that point later on. Right. Now, if you look at the type of relationship we can talk about, using min-max notation, especially the UML notation, this is how we represent. We represent both minimum value as well as maximum value. Now here the minimum value is 0. The star means many. So how do you pronounce it? You can say, okay, this is 0 many. If you take this one, 0, 1. So the minimum is 0, maximum is 1. Here we have just 1 indicates 1 and only 1. And last one, we can talk about 1 or many. The minimum should be 1 and, then the other one indicates a many. Now let's take an example. Now when you take an employee, there could be 0 or more payroll deductions, right? So the description is employee can have no payroll deductions or many deductions. Right. Now the second example, employees can have no spouses or one spouse. So there could be some employed without any spouses, and in maximum, you can have one spouse. Then office manager manages one and only one office. So that's what sales office. Minimum is also 1, maximum is also 1. When you take an order, there could be a 1 or more items, right? So this is 1 or more. So I hope now you understood the cardinalities. Now here is an example of the class diagram. Usually you have set of classes, and remember class represent as a rectangle with listing of their names, attributes, and the methods. And then you have relationships with the lines, with labels, and then finally you put the cardinalities. So if I go from here, we can talk about the cardinality. This one, managers relationship, we have 1-to-1. So what it means, when you take a manager, you manage one sales office. If you take from this side, one sales office can be managed by one sales manager. Similarly, if you look at this relationship, order can have 1 or more items. An item will be in a 0 or more orders. So there could be some items are not included in any of the orders. Okay, so now I think you should have an understanding about the difference of class diagrams. So here we represent classes. It's not only if you compare its entity relationship. So in entity relationship, we don't talk about any methods, right? But here you can see we have all the attributes as well as methods are here, right? And the line indicates a relationship, and then cardinality will tell us object, how they relate to each other. Right. Here is another example. You will see there are different notations people use. So don't confuse when you see these examples in different books in the internet, because there could be slight differences. But I took this diagram from Navate's book, usually one of the textbooks extensively used in database management systems. So in that example, we have a couple of classes: employee, department, dependent, project, and so on. And then we have lines indicate the relationship. Now, for example, in this one, we can read it as employee works for a department. And you can see 1 and 1. So this notation is slightly different from previous one. In previous, we just had 1. Here we have 4 and many. Like in a department, you can have minimum of 4 employees and more. Basically, it should be read it as 1 or more compared to the previous one. Likewise, you can have department can control many projects, and a project can be controlled from one department. So that's how we should read it. Right. Okay. So I hope you can refer more examples to understand how we can represent UML diagrams. Another example, again, slightly different version. So in this representation also, you can see the classes and their relationships. Here we have some inheritance here, because bank account, there could be two bank accounts could be as current accounts and saving accounts. So this is kind of a superclass subclass relationship, which means these subclasses can inherit all the attributes as well as methods from the superclass. So both current account and savings account, you have an account number and a balance, and then you can get the return balance and update balance. Whereas current account, you have two very specific methods: calculate charges and calculate the interest and so on. Right. Another example. So in this case also, we can have a superclass subclass relationship. We have person, and then person can be divided as employee and customer, or you can say this is a relationship. Employee is a person and customer is a person. Similarly, employees also can have like two subclasses. Shop mechanic is an employee and salesperson is also an employee. Right. And then when you talk about the membership, these are actually members of a team. So that composition is represented here as well. Right. Now here, customer offer. So customer makes an offer. So you can see this is a relationship. And the salesperson writes here. And the offer, you have list of vehicles. So here we have vehicle. So this will indicate another way of representing class diagrams. Right. Now, main things to notice in class diagrams, or when you draw the class diagrams, you first identify all the key classes, their attributes, their methods, and then you should also identify relationships. And then finally, you should identify their cardinalities. Right. Now that we have discussed about the class diagram, right? You will actually going to draw class diagram later today with the session, but for the time being, remember the steps that you need to follow. Okay, now we have discussed about the use case diagrams, and then secondly, we talk about the class diagrams. Now we are going to talk about sequence diagrams, right? So sequence diagram, usually now we talk about the classes in previously, but how exactly they interact? Like, what is the sequence when something happens between classes, when it is happening? So if you want to represent that timing information, we call sequence information, we are going to use what we call sequence diagram. Now, in sequence diagram, we have a couple of things we need to identify. Usually you have classes. So classes are indicated like this. And this lifeline, this dotted line we normally call lifeline. Lifeline indicates the existence of the class, right? So for example, the class 1 is the line indicates the duration. And class 2, you can see a cross here, which indicates that. So that it will be the end of the lifetime of class 2, right? And then once you have the lifeline, there are like focus areas, the focuses we normally call, which indicate actively, interacting. So for example, here, you can see class 1 passes a message to class 2, and class 2 actually respond to that message. And then once you respond, that is the end of the lifetime of class 2, right? And this will reach out here. So this kind of representation can show you the dynamics of the interaction, especially among the classes, right? Now the terms that you need to know, the classes usually we will represent as rectangle, and we will have names inside. And then depend on what we do, we can see classes can send or receive messages. And then we will have lifelines. They are identified using a dash line. And this will indicate the time during which the object is able to interact with other objects. And the cross mark is the end of the lifeline. So you can see from the previous, so this is the end of the lifetime of class 2. Then there are message passing in between. So messages we will identify using line, and arrow will show you the direction, right? And then you can have a message or label. That label shows you name of the message, right? So it can talk about like what is there. Finally, you have focuses. So you can have like the small vertical boxes, which actually cover the timeline, and which indicates when the object send and receive messages. So focus area will indicate when this will send or receive messages. Right. Now let's take a example from our previous class diagram, right? So we had some object relationship diagram, and also with the information what we have right now, we can come up with how a student actually register for a class. So when you talk about this exact happening and the timings, we have to first list all the classes are involved here. So it could be student, manager, fitness class schedule, and registration record. So you see that the student is the one who start this interaction. First, student requests fitness class from the manager. And you can see, so this is also start the same. When there's the student comes with the student, first of all, manager has to check the schedule. And if the schedule is free for the student, then manager can notify the students that the time is free or time is available. And then student can pay. Right? And once student pay, then that we can use to register the student. And this will indicate the registration record. So you can see, as the name implies, we can see the sequence. So this is the first one, the second one, the third one, the fourth one, and the fifth one. So clearly indicate how exactly this will happen, how student registration happens with this diagram. Right. Some more examples. I have listed you the links for your information. So we have customer, shopping cart, order, and item. And you can see customer place some orders in a shopping cart. You know that when you interact with the web pages, website, so sometimes when you purchase things, you can first purchase and put into what we call the shopping cart. So the customer is the one who creates the shopping cart, and that is the starts of the life, the focus. And then, first of all, the shopping cart can get the total, and then it will interact with the order. So to calculate the total, you need to know all the item prices. So the order has to interact with the item and get the item price. And once you get it, you can calculate the total price. And then finally, you can return the information about the total price. Right. Now that we have talked about the use case diagrams, then we talk about class diagrams, then we talk about sequence diagram. The next thing that we need to discuss is state transition diagrams. Now, state transition diagram means the object state will change from one place to another. Now, for example, take your student status now, right? Initially, you are not a student in this university. Then once you register, you became a student in the, let's say, the first year, second year, third year, final year, and then you will become alumni, right? So any object in the information system may change the state. Now, let's look at another example. Let's take account in a bank. Initially, you have to create a bank account. It could be a new account, and it could be an active account when you make deposit and withdrawal. And sometimes you can, if you're not operating the account properly, then it can become, you know, you can say active, inactive, right? So after some time, they call the term dormant, right? So if you don't use a particular account for some time, they can make it a dormant, which means you have to reinstate the state. So state transition diagrams can represent different states of the classes, right? So that indicates how the state will change from one place to another place, right? Okay, let's look at with an example. So this dot will indicate, or this small circle will indicate the start of or opening an account. When you say opening an account, you will get the first state, that is new account, right? You just opened account, then account become a new account. When you make your deposit, it becomes active. So active. So after using, sometimes if you're not using it, bank can close us, or sometimes you can make the decision to close this. So what happens then? This becomes a closed account. So this indicates the end of this, because when you close, this is, right? This indicates the end of it, start and end. Now, sometimes the accounts, you can have some assets and they can be frozen. And then once you release it, then the account can become active again. Right. So this is what we call the state transition diagram. Last one, we are going to talk about the activity diagram. So activity diagram, you can talk about as a flow chart, and it shows you the action and events and when they occur. So we can also going to use the active diagrams. We can identify the order, and then we can order which actions we want to take place, and then we identify the outcome. Right. Now, let's look at an activity diagram. So in this activity diagram, you can also see how the activity happens. So start when you need, like customer needs a cash. So customer insert the ATM card. ATM card is accepted. Then you have to enter the PIN card. PIN is accepted, and then you are going to request cash. If you have enough funds, then it will change the balance and it provides the cash. But let's say you don't have enough funds, then you may reply back to the user saying that sufficient funds are not available, and then ATM can notify the customer. So you can see it will show you how it happens. Right. Now, we talked a lot today, but I think as the last part of this, let's work as groups and try to understand the concept that we have discussed within the class, right? Okay, so what we are going to do next, we are going to do a small group exercise where I'll put you in a set of groups, and then we are going to use some object modeling tools and techniques within this group work. So what we are trying to do is we will see when you are given, you have to select one of your organizations. It could be a hospital, it could be a university, it could be somewhere, it could be even a library. So, and then once you identify information system to develop, you can identify some actors and also user cases, right, which indicate some functionality of the system. Now, for example, if you select a university, so the student has to register. So that could be a one use case. So likewise, you identify the possible actors and user cases, and then you need to create a user case diagram. And then you can choose one of these, and then you can create the class diagram. And finally, I want you to think about the creating sequence diagram, right? So what I'm going to do, I'm going to share you the description through the WhatsApp. So everybody is access what we are supposed to do. And then I'll put you in group so that you can start working as a group. Then after finishing this, just upload. You don't have to prepare nicely. You can work with the others. Whatever the work you have finished up to 1 o'clock, you can submit, right? You don't have to do anything extra, but I would like to see you at least try these different, tools and techniques to represent your information system. Right. Okay. Okay, so I have shared the description. Can you confirm whether you have received it? Maybe you can raise your hands.